On today's video, we're going to explore and restore the stylish COMPAQ Deskpro 386S. The COMPAQ Deskpro's claim to fame is that it beat IBM by 7 months by releasing the first PC based on Intel's 386 CPU. That was an earlier version of this machine. This model here was released roughly in 1988. This one is in a pretty rough condition. All the dirt and grime is overexposed on camera, so you can't see most of it. But I'll do my best and see if we can make it look nice again. I have managed to find what I think is the matching display, but I'm still missing the keyboard. And these machines were actually sold without a mouse. But I've got a decent match here, so this is gonna have to do. And I'll keep looking for the matching keyboard. And my notes on the machine here says that it boots from floppy. But that was many years ago, so I don't actually remember anything about this machine. And with the camera adjusted for dirt and grime, here is what it actually looks like. So this is going to be a tough one. The display on the front panel has gone yellow from age. At the back it has a stylish plastic cover to make it look nice. But with the discoloration going on here, it actually looks pretty crappy. This COMPAQ has an international power supply and a very long serial number. Now let's get inside and see what we're up against. So let's remove the thumb screws at the back. And I think we can pull that lid off. Ooh, it's a smelly one. We've got lots of dust bunnies inside. And more dust inside here. Oh, and apparently I forgot to remove the battery. But it doesn't seem to have leaked. Okay, so it's my lucky day. Time to buy a lottery ticket. And apparently it's also home for spiders. We've got plenty of cobweb here. And here's our dead little spider. And apparently we have the expansion card in this machine. Now that is great news, because these are probably impossible to find separately. But it doesn't have the extra add-on PCBs here. So that means we only have a few megabytes of RAM. But at least we have some. Without at least this card here, these machines are pretty much completely useless. I don't quite remember if they have 0 RAM on the motherboard, or perhaps just a little bit. We'll check later. On this top cover here we have the switch settings. That is super useful. This is a pretty famous machine, so they are probably available online. But if not, this is incredibly useful. On this side we have another sticker for the 16 MHz memory expansion board. You can see in this picture here that it has 2 PCBs added on top of the expansion card. And I was kind of hoping we would find a set of these in the machine, but we didn't. But at least we have the card. For this project I actually have the matching screwdriver, because I used to repair COMPAQs in the early 2000s. Now this screwdriver was already vintage when I got it back then. This screwdriver has saved tons and tons of vintage machines, not just COMPAQs. Okay, the first part to come out. Just a big plate. It's actually not obvious what it's for, aside from holding that sticker. Underneath that plate we have a double density or high density drive. We're gonna have to check those numbers later and see which one it is. I think double density was standard and high density was optional. And then we have the hard drive. So we're actually off to a pretty good start here. The only thing I would have wished for here would have been those RAM modules. And a 5¼ inch drive, of course. That would have been neat. But those were extra. And apparently the original owner didn't bother to buy them. Okay, so we already have different length of screws. That is kind of annoying. So I'm gonna have to keep track of these. Okay, let's see if we can pull that hard drive out. We've got a Connor drive. I've got tons of these. So if it doesn't work, I'm sure I have a replacement. This guy here is a CP3041 type 22. I don't remember what the size is, but we'll find out later. And it has a COMPAQ sticker, so probably the original drive. Most of my Connor drives actually still work, but some of them have issues with head stiction. Now here's our second quirk about these machines, aside from that RAM expansion card. Before we continue, I'd like to thank the sponsor of this video, PCB. I just ordered some really interesting PCBs for some upcoming videos. if you have never ordered PCBs, let me show you how easy it is. So first you just pick your favorite project at GitHub, and then you download the Gerber files. And next you go to PCBWay.com, and here you can just click on PCB Instant Quotes. And here's the link to upload Gerber files. And then you got this button here to add Gerber files. And then you can just point to the zip file you downloaded from GitHub. And that's basically it. If you want to, you can make some changes down here, but they are not necessary. So you can just save it to cart and finish your order. And that's how easy it is. I like to check the PCBs in KiCad before I place my order. KiCad is a free software, so you can just go ahead and download it. And then you go to File and Open Projects. Unzip the zip file from GitHub. And then click on the project file. And then you can click on PCB Editor. KiCad has a built-in 3D viewer that I like to use to check the PCBs. And this is what our PCB looks like. There is also a PCB Way add-on you can use in KiCad, so if I press this button here, it will take us straight to PCB Way, and our new PCBs are ready to be ordered. Now let's continue the video, and in a couple of weeks we will try out these Zulu SCSI cards. Thank you PCB Way for supporting this channel. Instead of installing just regular drives in these machines, they went with drives with this really weird connection, and then a PCB that turns it into a regular diskette drive. So that's pretty bizarre. They could have just skipped this PCB here and installed a regular diskette drive. At least that's what I think is going on here. So let's remove these two blanks next. And I wonder if we can install CD-ROM drive in here. That would be a really practical thing to have in this machine. Probably not. It seems to require some kind of special rails here. So let's hope there are printable rails available. We actually have a third type of screw here. Okay, I think these screws are actually holding the entire drive cage in. But I'm gonna go for a complete disassembly here. So I'll remove that front bezel from the diskette drive too, because this machine badly needs a wash. And yet another type of screw. Before we remove that drive cage, I think we should remove this cover at the back, in case the drive cage is held down here somehow underneath the cover. Well, at least all the screws are T15s, so I just have to keep track of what length goes where. Let's see if it comes off, and it does. And here's what the original color probably was, and this is what it looks like now. This machine actually has PS2 connectors. That's pretty early for a clone. So they were introduced by the PS2 system in 1987. And I think this machine is from 1988. So they were pretty quick to clone it. We can also see at the back here that we have built-in VGA. And a pretty disgusting fan. Okay, so the drive cage seems to be held down with hooks at the back here. So let's turn the machine around. See if we can unhook it. No, we've got more screws. Okay, let's try again. Okay, it slides out. Okay, I was expecting this whole drive cage here to come out, but we only got this plate with the floppy attached. So I think to install a CD-ROM drive, we probably need similar plates and install down here. So maybe it's simple to fabricate. As you can see, it doesn't have the usual screw holes on the side here. This drive too has a COMPAQ label. So I think we have a mostly original machine here. That's always good. I'll remove this drive from the bracket too, to make it easier to clean. So as you can see back here, it has a much smaller connector than a regular floppy. And this board here converts it back to standard edge connector. At least that's what it looks like. Well, we have one electrolytic cap here, but no visible leaky caps on this side. So let's check underneath this PCB too. To remove that PCB, we have to disconnect all the cables inside. So first we have two flat flex cables for the two heads. And then we have a connector that I think is for a sensor here. And the third connector is for the stepper back here. So now we can fold this PCB over and check underneath. Okay, this is looking good. We've got two electrolytics here. They are not leaking. Okay, good. So this is probably a working drive that just needs some cleaning. We'll check later what type of drive it is and if it needs an upgrade. Okay, there are actually two more screws that I think we need to remove to get the drive cage out. Well, I'm not sure, but I think we have to remove these Molex cables too before we remove the drive cage. Okay, let's see if we can remove that drive cage next. No, we can't. I think we have to remove the fan first. Quite possibly by pushing on these tabs. Or maybe this large tab on this side here. Yeah, that's it. It's actually quite different from all other machines I have worked on so far. But the build quality reminds me of an IBM. This is some seriously thick metal. And one really good part of this project is that I haven't seen any rust yet. So it seems to have been stored pretty well. And all that dust is of course easy to wash off. I'm going to remove the fan from the bezel too, to make it easier to wash. Next up we have the floppy cable that can't be removed without removing the power supply first. Love that power switch. Nice and chunky. So these machines were incredibly expensive back in the day. But if I'm not mistaken, the IBM was probably even more expensive. Maybe I'll check and put on the screen here. Okay, I think that freed up the power supply. Okay, so now we have access to the hard drive cable and the floppy cable. And the power supply is hooked up to the motherboard with a custom cable too. That sits very firmly. Wow, that thing is stuck on really hard. Okay, finally. That took some effort. Okay, place your bets. Are we going to find some smelly refills or Vima branded caps inside here? And my usual disclaimer, of course, please don't mess around inside power supplies. Some of the caps inside can be charged with mains voltage, even with the cord unplugged. And it has a label in 5 languages to warn us. Okay, all bets are off. Let's see what we've got inside here. Well, we've got some cobweb. So the spider has been inside here too. And we've got some gunk on one of the caps here, but that's probably just glue. Or perhaps a fried spider. And then we've got some other brand on the safety caps. So no refas, no Vima. But we definitely need to investigate this cap here. So I'll take the PCB out too. And apparently we need a different bit inside here. So the shape of this power supply looks quite similar to what we would find in a PS2 Model 50 or 70. So I wonder if COMPAQ just cloned it. Or maybe it was just a standard. To get the PCB out, we have to disconnect the 2 LEDs on the front panel and cut a few zip ties. And we have to disconnect the power switch too. Wow, that thing is stuck. Same thing with the IC connector at the back here. And we have no choice because that suspect cap has to be checked. And now we can actually see the brand of the power supply too. This tiny logo here is from AMTECH. And they made tons of power supplies for IBMs too. So they probably designed the power supply for both companies. And apparently it's still not enough disassembly. We need to get that power switch out. Okay, let's try again. Well, that actually took some fiddling. And eventually it came off. And just like in IBM's power supply, we've got this piece here. Transfer heat from this guy here down to the chassis. So we need to remember to reapply thermal paste. And here is what worries me. We've got some gunk here. Yeah, unfortunately that is a leaky cap. Oh crap, that sucks. This is the third video I start recording this week. I had to stop recording the other two because I was missing parts. And I have not prepared this one with fresh set of caps either. So that is why there wasn't a video last week. And I'm not too keen on putting a third video on hold. So we'll just continue and I'll look through my stash and see if I can find a replacement cap. So keep your fingers crossed. And that power supply is custom, of course, so we can't just replace it just to finish the video. And speaking of custom, here is our expansion board with the RAM. And apparently this machine is a few years newer than I thought, because the dates on these chips here are from mid-1990. And this board is also marked 16-bit 1 megabyte. So that's all we have. 1 meg of RAM in a 386. And I think finding these extra RAM boards to install here, that's probably really difficult. So our best hope here is that someone who has them will reverse engineer them. Because there is probably a lot more of these machines out there than RAM expansion cards. We also have some nasty little tantalums, but I probably have some in my stash. And if not, they are from 1990, so there is probably a few more months left before they explode. Next up we have the lucky battery that hasn't leaked. Okay, and our lucky battery here is a 3.3 volt lithium manufactured by Eagle Pitcher Industries. Warning, do not recharge. So this should be easy to replace. And it has been completely sealed in this plastic package here. So it's gonna have to remain a mystery. But I will reuse the original cable and install a modern battery. Well, aside from the speaker here, we only have the motherboard left to remove. Too bad COMPAQ went with that custom solution on a large PCB instead of regular SIMs. Okay, here comes the motherboard. The board is incredibly dusty, but I noticed something here. We've got some more RAM here. So hopefully we'll have 1 more meg here. And 2 megs would be a hell of a lot better than 1 on a 386. I also checked some dates here. And the dates on these chips are from mid-1992. So that's probably when this machine was made. Okay, one last beauty shot before the wash. Okay, everything is back from the wash. Let's start with the front panel. It looks pretty decent, but it has yellowed and slightly more on this side than on the right side. But it's not bad enough to worry me. So we can go ahead and retrobrite the front panel. Many badges don't get damaged by peroxide, but some do, so let's see if we can remove it. So I'm carefully going to heat the panel from the back. And here you can clearly see what the color difference is. So this is probably the original color, or at least close to it. So I'll keep reapplying heat from this side. See if we can pry that badge off. And hopefully the heat will dissolve the glue underneath. It's quite hot, but still stuck. So we may have to cover it instead. But I'll try some more first. Okay, now it's finally coming off. That was a stubborn glue. Still stuck to this side here. And I don't want to use any force because we could bend the badge. So I'll apply some more heat instead. I'm just using a cheap heat gun, by the way. And here comes the badge. I'll remove that old glue. And completely dissolved. And turned into goo. We also have some black scuffs here that didn't come off in the wash. So let's try with IPA. And a magic eraser. And it seems to be working. Okay, all the scuffs came off. And I soaked the panel in peroxide. Unfortunately it's pouring outside. So I'm going to use the space heater and heat the panel up for 20 minutes from each side. So 80 minutes in total. And this is 9% peroxide, by the way. And then I'll rinse it and we'll check. And then we have this panel here. And unfortunately it's not going to be as easy because it's very unevenly yellowed. If you have ever tried to retrobrite a piece like this, then you know that we're going to get 2 shades of beige. And it's not going to look good. But there is actually a solution for this. I have managed to fix 4 similar projects. Here's a good example. So I'm preparing this panel for a future video. And it was just as evenly yellowed as this panel here. It was mustard yellow at this end here. Then it got better towards this end here. And the way to fix this is to just leave it out in the sun for about a week. So what tends to happen is that the dark yellow parts, like on this side here, turns into this slight shade of yellow. The camera actually overexposes it a bit. It is still yellow, but it's way better than this mustard yellow part here. And this side here that wasn't as yellow as this side actually turned slightly more yellow than before. But the trick here is of course to get it as evenly yellow as possible before you apply the peroxide. And I have successfully saved 4 panels this way. And this is my 5th attempt. And as far as I can tell, it is working. And we'll see the final result in the Amiga 4000 video. But since the rain is pouring outside, I can't really do anything about this panel. So unfortunately, this panel here is going to have to be for the follow-up video. And there's definitely going to be one, because I just ordered some really cool stuff from eBay for this machine. Okay, next up we have the main concern with this project. And that is the power supply, of course. Now we could be lucky, and perhaps that brown goo here was just spider poop, if such a thing exists. Let me check. Okay, and according to Google, spider droppings are not solid pellets, but are typically small liquid and appear as pinhead-sized splatters or drips. So I don't know, it probably was electrolyte. But since I don't have a set of caps for this board, let's try out one of my new toys. And it's this thing here. This is a new LCR meter from FNIRSI, the LC1020E. And full disclaimer, it was sent in for free. So perhaps this can tell us whether that was spider poop or electrolyte. Let's check the specs at the back here. So it can test caps at 100 Hz, 120, 1 kHz, 10 kHz and 100 kHz. Accuracy is 0.3%. It has a 2.8 inch display. The measuring range is 0 to 100 Henry, 0 to 100 millifarad, and a resistance between 0 and 10 megaohms. And I think it can measure at 0.1 volts, 0.3 volts and 0.6 volts. So this is way better specs than my old ESR meter. Okay, let's get inside and see if it's any good. Very neatly packaged. It includes some leads, USB cable, a manual, some sort of brackets, and a second set of super fancy leads. Well, let's unwrap it. Okay, first impression, it feels really solid. Let's peel this off. And I'll quickly check the manual before we move on. Okay, I pushed on all the buttons and flipped through the manual. And somehow I managed to set it to Chinese. So the first thing we need to do here is to set it back to English. So I'm going to press and hold the OK button here. And I'm gonna guess this one is language. Yes, okay. So that was an easy fix. And while we're in here, let's go down to volume and crank it down significantly. And if we push down again, we get 2 more options here. We can now calibrate the tool. That means we need this thing here. So we can short these 2 test points. And I don't think we should press OK. Busy. Okay, well, let's skip ahead here. Okay, that took less than a minute. Now I think we need to remove this thing here. Switch to open. And run the calibration again. And this calibration has to be done again if you attach the Kelvin clips or the probes. Okay, and we're done. So a long press, I think, should take us back. Okay, I think we're done in here. That's all the settings I need to do. Now let's try it out with a new cap. I've just used this cap to test something, so it's brand new. Even though the leads look like crap. So I'm going to set the frequency to 100 Hertz and the level to 0.1 volts and the bias to 0.5 volts. And speed I'm going to set to slow. Okay, so on the display we've got two measurements. The first one here is set with this button here. So let's set it to capacitance. And the second measurement is set with this push button here. So we're going to set it to ESR. And then I'm just going to put the cap in the meter. Oh, I forgot to mention, this is a 1000 micro 16 volt cap. So one obvious issue here is that I would need a much more expensive meter to tell you how accurate these values are. So unfortunately I can't tell. But being a brand new cap, I'm gonna say these values are at least very close to being accurate. We're getting 986 microfarad and 0.08 ohms. For this cap, that value should be roughly 0.1. So those are good values from a good cap. So let's remove the protective plastic from the Kelvin clip. Well, that was easier said than done. They went all in to protect these connectors, and it's designed to be installed here, of course. Now we need to short these two guys and do a long press on OK and go down to calibration again and switch to short and start. I'll skip ahead here, but this is going to be the same procedure as when we did the calibration with this thing here. And then I'll redo the calibration with the circuit open. Now let's measure this guy again with the Kelvin clip. So let's change it again to 100 Hertz, the level to 0.1 volts and the bias to 0.5 volts. We're getting very close to the same value. So that tells me these clips are probably pretty good. Okay, now let's find out if that was cap juice or spider poop. So the suspect cap here is Nichicon PL series, 1000 micro 10 volts. So let's first test it in circuits and see if it works. This isn't looking too good for our cap. Now this could be caused by the measurement being in circuits, but we're getting 3000 micro instead of 1000. ESR is still good though. Now let's try with a different frequency. So I'll go all the way up to 100 kilohertz. And now I'm getting nothing. Let's try 1 kilohertz. Still 3000 micro. And at 10 kilohertz and above, we're getting nothing. Okay, so in that case, we need to test it off circuit. I'll start by adding some fresh solder while the desoldering gun heats up. By the way, I've been using my FNIRSI solder station for about 6 months now. I've been using it every week since I got it, and on some weeks every single day. And it has been working absolutely perfectly. So that is of course why I gladly accepted the new ESR meter, because I have a really good experience with their stuff. Okay, the soldering gun is nice and toasty. Let's get that cap off the board and see if we get the same crazy measurements. Oh no. We've got a drop of something underneath this cap. And here's our Nichicon 1000 micro 10 volt cap. PL series. I think that M stands for 105C. And it actually also says 105C here. And I think that's a date code from 1990. Okay, all settings as before. Let's see what it measures off circuits. Wow, that's pretty bizarre. it actually still measures roughly 1000 micro. The ESR is slightly off. It may actually be within specs, because this is a pretty old cap. So there you have it. We have seen this many times on this channel. Caps that still measure good, but are clearly bad. So just measuring them isn't enough. I think we've had like 3 or 4 projects where the measurements were good, but after a recap the machine started to work again normally. So there's a lot more to caps than just the capacitance and the ESR. But the ESR meter is great. I'm super happy with this. There are several benefits to this ESR meter compared to my old one. So first of all, we've got both measurements on the same meter here. So previously I had to use 2 meters, one to check the capacitance and one to check the ESR. The second benefit is that I can change the frequency. My old meter was set to one frequency, I don't remember which one, but that is a major benefit. And another benefit for me is that it can also measure inductance. I actually have a project where we need to check the inductors. So big thanks to FNIRSI for sending it in. This is gonna come in handy in many projects. And now let's get back to our issue here. The nasty electrolyte that has left the cap. Well, I'll be damned. Look what I found in my box of leftover caps. These are 1000 micro 16 volt caps, rated for 105C. Apparently I ordered too many when I recapped the Color Classic. So this is a lucky COMPAQ for sure. And these other 2 caps here are 1000 micro 10 volt caps too, just like the leaky one. So we can at least replace those. And then I can do a full recap of this board later. Nichicon PL series are actually known to be leaky. At least when they are this old. But I mean, we really shouldn't complain. They are 35 years old after all. They probably weren't designed to last this long. And sure enough, this guy has a drop of electrolyte underneath too. Now I have washed this board really thoroughly, so there was probably more before the wash. And there is some electrolyte on the PCB here too. So I'll clean this mess up before we install the new caps. I also noticed there is some mild corrosion on the legs of this resistor here. That was probably caused by that cap. So I wonder how long these worth caps are going to last. And I wonder if I'm still going to be messing around with this machine in 35 years. Well, one thing that I have learned about nostalgia, and that is that it comes as a surprise. So I recently started to miss my old CDs. And I didn't even like CDs back in the day. So I actually switched back to vinyl. But for some weird reason, I kind of miss them now. I wish I hadn't thrown them away. Well, at least we have 3 happy caps on this board. And to be perfectly honest, I'm not sure it actually needs a full recap. I mean, those caps are known to go bad. What do you guys think? Should I do a full recap or not? Well, I checked the remaining caps and they are all Marcon branded CEUS series. I decided to remove a few of the remaining caps and checked underneath. There were no signs of leakage, and according to my new ESR meter, those caps are still good. I also remembered to reapply some thermal paste underneath the rectifier and then reconnected all the cables. So this power supply is ready for a test now. Next up we have the diskette drive. I don't see any signs of leakage, so I'm going to leave these 2 caps alone. And if this drive gives me any trouble in the future, I will replace them of course. But I have just too much stuff to recap without having a specific reason. So I tend to leave caps alone, unless the machine is misbehaving or if it has caps that are known to go bad. And obviously if they are showing signs of leakage. But I'm gonna say these are probably good, so let's leave them in. And same thing with this cap here. I don't really see any reason to replace it. I'll just leave it in. And if the drive works well, that cap too is probably good. I'll place a few drops of deoxits inside all the connectors before I reconnect the PCB to the heads, the sensor and a stepper. The final step is to apply some PTFE on the worm shafts and a rail hiding away underneath the heads here. And that's enough for most drives. Some drives also require that you grease these hinges here. I also checked the part numbers for this drive. It's a Citizen drive made in Japan. Part number OSDA53B. And this drive apparently is a high density drive. These machines were also available with double density drives. I also went through my stash and I found another one of these. So I think we should install it in the machine too. I think it's going to look pretty good with dual drives on the front panel. Even if I don't really need dual drives. But unlike the other drive, this one here has a nasty surprise underneath this PCB. So the caps in the other drive may be good, but these are not. They are known to leak like crazy and completely destroy the PCB. So we need to replace them before we install this drive. By the way, I didn't clean this drive, it actually came this clean. So I don't think this drive has ever been used. This drive has that same COMPAQ sticker on top of the cover. But it also has a COMPAQ spare sticker with another part number. So I think this is a spare drive that ended up never being used. And that sticker is super nostalgic to me. So this drive is actually 4 years newer than the original drive. Luckily these guys have not leaked yet. So this is a lucky drive. We'll grab these with the tweezers. So I'll put a blob of solder on each tip. And then we'll just grab that cap. And just wait for a few seconds. And then pull it off sideways. And then we'll just repeat the process with this cap too. I love my tweezers. They make recapping a board with SMD caps so easy. That only took a few seconds to remove the two caps. I'll remove the old solder from the pads before I install new caps too. By the way, there is some noise in the background. And that is the space heater finishing our front panel in peroxide. I'll use some IPA to clean up the flux. And then add a small splash of solder to one pad for each cap. So the small cap here is a 22 micro 16 volt cap. And since I mess around with IBM PS2s, I've got plenty of those. Now I'll reflow that solder and place that cap. Then I'll solder a pad on the other side. The larger cap next to it is a 33 micro 25 volt cap. And apparently I've got plenty of those too. I'll clean that flux up. And I think we can consider this drive saved. A tiny cap like this can really cause massive damage on the PCB, as you may have seen in some of my other videos. On one of my PS2s, the cap choose had found its way to one of the chips and the legs had started to fall off. So that is how bad it can get. So if you have a Deskpro 386S, get that drive out and check those two caps before it's too late. Next we have the case fan. So pull that sticker out of the way so we can access the bearings. And then I'll place a small drop of oil. And hopefully it will find its way down into the bearing. And hopefully it will make the fan nice and silent. And then I'll just put that sticker back on. Okay, next we have the battery. So this is a 3.3 volt non-rechargeable battery. So we can replace it with a regular coin cell in a holder like this. But we are going to reuse that connector because I don't have any of these. So I'll just snip that battery off. And the wires on the CR2032. And the original wires actually just refuse to take solder. So these have some corrosion on them. I guess that could be the battery juice that has started to find its way out through the wires. So let's try with some flux and see if that helps. Well, it's still stubborn, but now it's actually taking solder. Okay, so that fixed it. Okay, wires are soldered. So I'll put one piece of heat shrink on one of the wires so they don't short. And then I'll cover it with a second layer so it looks neat. This is always so satisfying to see the heat shrink to size. I could watch this stuff for hours. Cut a piece of Velcro to size. And I'll stick it on the back of the battery. And I'll put the other end on the case. We're almost ready for a test. The last thing we need to do before we can test that machine is to run COMPAQ SoftPak 0308 on a machine that has a diskette drive. Ideally a COMPAQ, of course. To accept the license agreement, type agreed. Jeez, they were taking this very seriously. Okay, and that created another file, QRST.exe, so let's run it too. So this is SoftPak Diagnostics version 8.0 Rev B. Let's insert the diskette and press enter. So this machine predates the usual way of setting the BIOS. So it's quite similar to IBM PS2s of the time. And it requires a special diskette to set the BIOS settings. I guess we could check what's on that diskette. Well, it's got stuff on it. I guess we could reboot the machine. COMPAQ Personal Computers Setup, Inspect and Diagnostics version 8.0. Yeah, this looks right. So I think we have a working diskette we can use on the Deskpro 386. And we are finally ready for the smoke test. So here goes. Okay, the fan spun up. The green LED on the power supply lit up. The heads on the diskette drive moved. And the red LED lit up on the motherboard. Oh, the display is turned off. Yes, it posts. System option not set. Run setup. Insert diagnostic diskette in drive A. And we've got a keyboard error because I haven't connected the keyboard yet. Okay, that's a great start. So I guess I'll hook up a keyboard. Okay, keyboard connected. Next I'll run the cleaning diskette. It's spinning and the heads are moving. I'll run it for a couple of times to make sure those heads are clean. Okay, that should be enough. Now let's try the diagnostics diskette. Here goes. It's spinning and it seeks and it reads and it works. Awesome. So at least we have a working drive. So I'm going to run the machine without the RAM card first because I want to see how much RAM it has on the motherboard. Oh no, diskette IO error. So it didn't work after all. Well, I've had this happen to me many times before. If a diskette drive has been left unused for many years, they seem to need a few attempts to start working. But after a few reboots they tend to start working normally, and then they tend to work consistently. So I'm gonna reboot the machine a few times. Okay, and on the reboot it counted up to 1 meg of RAM. So I guess that's what we have on the motherboard. Okay, so I watched the heads move here, and the drive seems to have some issues reading from the middle of the diskette. So maybe that's a bad diskette. I'll make a new copy and we'll try again. Okay, now it works. Good old COMPAQ logo in yellow, orange and red on black background. That logo looks great. They should have kept it like this. Okay, so now I'm curious to see if that actually was a bad diskette. I wonder if it was the same old issue that the drive needed a few reboots. So I'm going to reboot again. Okay, it spins and it seeks. It reads. It boots. No, that was actually a bad diskette. Okay, well then we know. Well, now that we know how much RAM we have on the motherboard, we can include the expansion card. And it has these two special slots. So definitely not a standard card. Now let's just hope those tantalums aren't quite ready to explode yet. Now the system counted up to 2 megs. So we do indeed have a second meg on that card. And we've got a bad RAM chip. Oh crap. So unfortunately we don't even have 2 megs, because this card needs a repair. Not just new tantalums, but at least one of the RAM chips needs to be replaced too. Well, I was actually hoping we would test a generic RAM expansion card in this machine. But unfortunately we can't, because I don't have the manual for this card. And it's not branded, so I can't search for it either. And these cards can't just be installed in the system. You have to set these switches here to map it correctly. And this card here I think is mapped from 640K. So without the manual I can't set it to be mapped from 1 meg. So unfortunately we can't test it. And obviously if you recognize this card, then please let me know. Or if you have something very similar, because this is clearly a clone of something else. So the dip switches here may actually match the original card. But for now, 1 meg is all we have, unfortunately. Now let's try that second diskette drive. Okay, it spins, heads are moving, it seeks, it reads, it boots, and it works. So that's awesome. We've got 2 working drives. Okay, let's reassemble what we've got so far before we test the hard drive. I'll attach the cable for the hard drive now, since it won't be accessible later. I'll put the other piece of Velcro on the chassis back here and install the new battery. Easy to replace and no risk of leakage. The connector for the power supply was so hard to remove. I probably have some corrosion on the pins here, or perhaps the connector on the power supply. So I'll put a drop of deoxit on each pin before I reconnect it, and hopefully it will be easier to disconnect the next time. I think the fan has to be connected before we install the drive cage, because I don't think we can reach that connector once the drive cage is installed. The floppy and hard drive cables are really crammed in here. Yep, sure enough, that connector is not accessible now that the drive cage is installed. And I had to remove the drive cage again, because apparently one of the Molex cables has to be routed behind the drive cage. There are 3 of these cables, and the one that needs to be routed behind the drive cage is the shortest one. It's the cable that goes to the hard drive. And there is plenty of room for a CD-ROM drive down here, and it has an extra Molex. So all that's needed here is just some printed rails. So if we install a diskette drive in this slot here, we can see that it needs to be raised a couple of millimeters. But this is going to be for the follow-up video. And if you know if there are printed brackets already, then please let me know. But for now we'll go with a blank. I'll keep that spare drive in the second bay and install the original drive up here. Not a very useful upgrade, but it looks good. The floppy cable has 3 connectors, so I think that third bay is probably designed for some kind of tape backup. And onboard IDE probably doesn't have support for a CD-ROM drive. So I'm going to source a sound card with an extra IDE for the CD-ROM drive for the update video. Actually, I think I know what this plate is for. On some machines like the Amiga 1000, we've got the power supply on one side here, and then the cover sits quite firmly on this side too. I don't remember exactly how, but when you put a heavy display on top, the whole cover bulges down. So I think that's what this plate is for, basically allowing really heavy displays on top of the machine. If it was for the sticker only, they wouldn't have gone with this incredibly heavy steel plate. This thing is like 2 millimeters thick. Okay, the hard drive is back in its custom cradle. I think the most important thing if you're on the market for one of these is to check and make sure that you get all the custom brackets and that weird RAM expansion card, of course. And for no reason at all, this screw here is shorter than any of the other screws. Go figure. And the front bezel is back from Retrobrite. It turned out really good. The color actually matches quite closely to the badge here. Unfortunately, I can't say the same thing about the cover. It still looks like crap, so this cover needs a respray. So I'll try to find some paint that matches this color, and we'll respray it in a follow-up video. Well, retrobrighting stuff is not fun to watch. So I'm going to remove this panel on a warm sunny week. And then I'll fix it and have it ready for the follow-up video. Okay, let's put that cover back on and see what this machine looks like. Not bad. Not bad at all. This is a good looking machine. I like that dual diskette setup. It looks good on this machine. Okay, so let's run the setup diskette. Okay, and drive A is 1.44 meg drive. And our drive B is 1.44 meg 2. Numlock on. Okay, and it detected our hard drive. Type 22, 42.9 megabytes. 640k of base memory. 256k of additional built-in memory. And 128 COMPAQ reserved memory. Total COMPAQ memory, 1 megabyte. I wish we could have tried a generic card, but hopefully someone will recognize it, so we can set those dip switches. Well, there isn't much else we can set in here, so let's exit. And after the reboot we get a different menu. So now we have the option of testing the system. That option wasn't available before we had set the time and date. Okay, are all COMPAQ options listed? Well, we've got the 386 16 MHz SX, 1 meg of RAM, keyboard, parallel port, 2 diskette drives, 1 serial port, and a disk controller with a Type 22 drive. That looks okay to me. Now we can run the diagnostics tests. I think once should be sufficient. And I'm just gonna go down to the hard drive. I think a regular write, read and compare test should be sufficient. Okay, that was too quick to read. I'll try again. Fixed disk drive complete, so that was an incredibly quick test. So let's exit and reboot the machine without the diskette. And apparently this is a very long video because my camera just died. But what I was saying is that I think I know why you chose those weird diskette drives. When you insert or eject the diskette, it feels super solid. So these are fancy drives. So that's why I think they went with those weird Citizen drives. And we have a working hard drive. Unfortunately, it didn't have the original COMPAQ installation, if there was such a thing. It was just a vanilla DOS installation. Well, the camera apparently thinks I should stop here. So I'll upload here, and before you leave, like, subscribe and leave a comment. And if you want to help me make more content like this, consider becoming a patron. And I'll see you guys again next week.